All right, so for adding and subtracting fractions with like denominators, we talked about the fact that when they have a like denominator, that means that the bottom number has to be the same. And so when we modeled this type of situation, okay, first of all, we talked about how having this type of fraction, so if I draw a rectangular piece and I split it into 1, 2, 3, 4, 5 pieces, all right, and I color in 2 of those 5 pieces, all right, I have 2 out of 5 total pieces. And now we want to make sure also that the denominator, or that bottom number, that tells us the number of pieces in one whole, because that's also going to tell us how big are those pieces. Okay, so this cake, this rectangular cake that I drew, I split it into 5 pieces. That tells me how big they are. Okay, so now I have 2 of those 5 pieces of cake. Okay, great. And then let's say I add 3 out of 5 pieces. So again, we're going to draw this cake. We're going to split it into 5. They're the same size of cakes. And because I split both of them into 5, notice that this piece and this piece are the same size. And because they're the same size, because both cakes are split into the same number of pieces and each piece is the same size, we can actually combine these pieces together. We can put them together. So we have 1, 2, 3, 4, 5 total pieces when we add them up out of, and then the bottom number isn't, we're not adding all the pieces. It's not going to be 10, but actually that bottom number has to be how many pieces were in one whole. Well, in one whole, in one cake, there was 5 pieces. So it's split into 5. So our answer would be 5 over 5. So we kind of came up with different rules for that for our models too. And we said, okay, if I have 2 over 9 plus 3 over 9, we said, okay, the first thing you need to check is that the denominators are the same. If they're the same, that means the cake is split up into the same number of pieces, they're the same size, we can put them together. So then all you have to do, okay, so we check to see the denominators are the same. Now that they are the same, okay, we're going to actually just add up the tops. So 2 plus 3 is going to be 5. And then the third step is that denominator stays the same. So it does not change. So if it was 9, it's going to be 9 here, because the number of pieces that one of those cakes was split up into has not changed, okay? That cake was still split into 9 pieces. The top numbers changed because we put pieces together, okay? It's like having a pizza and having 2 slices left in one box and 3 slices left in the other. Well, you're going to put them all into the same box, but that box could only fit a maximum of 9 pieces still, okay? That hasn't changed. No, it didn't all of a sudden become 18 pieces, okay? So that one box. So that's the difference when we're adding and subtracting. And then we do have a secret step, and that fourth secret step is to simplify. And we talk about that more as we get into adding and subtracting fractions with unlike denominators where they're not the same. But that would be our final step for these, making sure that we simplify our answer. Okay. And now the same goes for subtraction. Let's say I have 10 over 12 minus 3 over 12. Okay. And I draw out my model and I split my cake into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces, okay, and I have 10 of those 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have 10 of those 12 pieces. Okay, well now what I'm doing is I'm going to take away 3 out of 12 pieces. So what that's telling me is, okay, I'm taking slices that if this cake was split into 12, I would take away 3. Okay, so I'm going to take away that 1 piece, 2, 3 pieces. So how many pieces am I left with? Well, I'm left with 7 pieces. And in one whole, there would be 12 total pieces. And so if you notice, it's the same thing, except we're just subtracting the top. So it's 10 minus 3, that equals 7, and then the bottom stays the same. And that's how we would add and subtract fractions with like denominators.